Okay, so we have 42. 42 is kind of a cool problem in that you notice you have x plus 1 and x plus 1. So that means, what am I multiplying x plus 1 by? So I'm multiplying x plus 1 by this x, right? And I'm also multiplying x plus 1 times this, right? And this piece, this x minus 4, is also being multiplied by this x over here, right? So this x is going to be multiplied by x minus 4. But that's not everything. We are also multiplying x plus 4, or x minus plus 1, by this piece right here. Now this kind of looks like a jumbled mess, right? But we'll see that when we multiply it out, it won't look so bad. So x times x is x squared. X times negative 4 is negative 4x. And we still have our plus 4. And we're multiplying this by x plus 1. Well, this looks like it can be factored again, right? 4 is a perfect square. X is a perfect square. Well, this really looks like a square binomial. We know it's a square binomial if this middle term is 2 times ab. So what is the square root of 4? 2. 2 times 2 is?
4.
It works out. So we have x minus 2 squared times x plus 1. And there's not much more I can do here. And that's about it. All right, so 45. Now 45, I suspect, is going to be somewhat similar to this.
Difference of squares.
So, and I hope I don't flail for a while on this one. So, I'm going to guess it's fairly similar to 42. And another thing I could do is I could actually multiply things out, put it together, and then factor it again. But in the spirit of 42, let's see what we can do. So we know that we have a times a plus 3 times a minus 3. And I factored this as a difference of squares. Minus 2 times a plus 3 times a plus 3. So now I'm going to try to look for similar terms that I can put together. So I noticed that they all have an a plus 3, right? Here and here. So I'm going to sort of put that by itself, a plus 3. And then, well, what am I multiplying a plus 3 times? Well, I'm multiplying a plus 3 times a and a minus 3. What else am I multiplying it by? I'm multiplying it by minus 2 times a plus 3. So now I need to simplify this, right? I can't leave an answer like that. It just fails the aesthetic test. So a times a is a squared. A times negative 3 is negative 3a. So we have negative 2a minus 6. And we're multiplying this whole nasty thing times a plus 3. Well, let's combine similar terms, and I notice that these are similar. Negative 3a minus is negative 5a, thank you. So a squared minus 5a minus 6 times a plus 3. Well, oh my goodness, negative 6 plus 1 is negative 5, right? So this can be factored as a minus 6 times a plus 1, and you'll see that the linear term works out, times a plus 3. And that's the answer, I think. All right, we got it. Hold up, the man says. Okay. So for number 48. Oh, yeah. Okay, so the first thing I'm going to think of is this. because it looks like these are all similar terms, right? And I notice that they all have an x in them. So if I factor out an x, I'll have an x on the outside, and then this will be x to the third. But you know what? X to the third is not going to help me out here. It's going to end up being a bloody mess, really. So grouping it there is not going to work. So how about this? How about grouping it here and here? And that has some promise. So x to the fourth minus x squared. They're both perfect squares, aren't they? So that is a... Okay, so I'm going to factor this as a difference of squares up here. So I have x squared... Oh, sorry, stop, hold the phone. I'm forgetting the first form of factoring. The first form of factoring is greatest common monomial. So what is x squared? So we're going to have x squared times x squared minus 1. Oh, now that's a difference of squares. So we're not going to lose our difference of squares. It's just going to occur a little bit later. What goes into both of these here? 4. We're going to keep this as a positive 4, I believe. So actually, you know what? No. Yeah, we're just going to take it out as a positive 4. So plus 4. And 4x divided by 4 is x. That's minus 1. So there we have it. So then, the next step, we have x squared. Well, you notice these are awfully close to each other, but they're not quite there yet, right? So I can't pull out that x squared and the positive 4 yet. What I need to do, though, is I do need to factor that difference of squares that we talked about. So we have x squared on the outside times x plus 1 times x minus 1 plus 4 times x minus 1. Now, you'll notice, just like some of our previous problems, we have a similar term here. So we have our x minus 1. And what am I multiplying that x minus 1 by? Well, I'm multiplying x squared times x plus 1 over here plus 4. And that's the plus 4 right there. So then, what am I going to do? Well, I'm probably going to multiply things out and hope for the best, right? All right. So we have x to the third plus x squared plus 4 times x minus 1. That doesn't look so good, does it? So the question is, why not? That's where you got?
Yeah, that's where I got.
Yeah. Well, I can assure you x minus 1 is in there. Well, factor out. So I'm going to go back and see if I've made any errors so far, because I'm not getting something that I would hope to get, because I'm not sure where to factor that from. And it's very possible that I have made an earlier error, and I'm going to run out of time. So what I'm going to do is I'm going to stop here and do the last one on a third video.